Experimental evidence appears to confirm the existence of one of the most mysterious phenomena in the universe: the capability of particles to influence each other instantly at a distance. The scientific community of the early 1900s assumed that such an effect is predicted by quantum mechanics. It became simply known as quantum entanglement. But those two words have long generated intense scientific debate. Albert Einstein had questions about quantum entanglement. He noted that quantum mechanics can only represent point-like particles isolated in vacuum, and so it's unable to predict their entanglement. Possible representation of the entanglement would imply superluminal communications, an event faster than the speed of light, and that would violate special relativity. To account for such a violation, Einstein and two of his graduate students, Boris Podolsky and Nathan Rosen, jointly published a paper in 1935 that became known as the EPR Argument. Their paper concluded that quantum mechanics is not a complete theory. Debate and discussion of the EPR argument continues to this day. On September 1st to the 5th, 2020, an international teleconference on the EPR argument was held, sponsored by the R.M. Santilli Foundation and the Family of Israel Foundation. One of the invited speakers at the teleconference was Professor Indranita Sharma.
The 2020 teleconference was dedicated to identifying the limitations of quantum mechanics, the study of the EPR argument, and to debate the lifelong research by Professor Ruggero Maria Santilli. It had contributions by numerous scholars on the proof of the EPR argument, as well as their applications to solve many alarming environmental problems.
Very early in his academic career, the EPR argument caught the attention of Sir Professor Ruggero Maria Santilli.
I've been a strong supporter of Einstein's view that quantum mechanics is not a complete theory since the time of my graduate studies at University of Torino, Italy in the mid-1960s. This was so for a number of technical reasons, including the fact that the quantum mechanics cannot provide a consistent representation of energy-releasing processes such as combustion or nuclear fusion, because these processes are irreversible over time, while quantum mechanics is strictly reversible. I therefore dedicated decades of my research life, jointly with colleagues from various countries, in the construction of a covering completion, if we prefer, of quantum mechanics into a new discipline that we propose under the name of Hadronic mechanics, that had an irreversible axiomatic structure from the beginning, so as to provide a consistent representation of irreversible processes from first axiomatic principle, and eventually contribute to the solution of our increasingly alarming environmental problems.
Hadronic mechanics was developed to represent fundamental processes in the core of stars.
When I joined Harvard University in September 1977, with support from the Department of Energy, I was requested to study the synthesis of the neutron from the hydrogen as occurs in the core of stars. I discovered in this way that quantum mechanics is completely inapplicable for a quantitative representation of the most fundamental synthesis in nature, that of the neutron, for a number of technical reasons, including the fact that the mass of the neutron is bigger than the sum of the mass of the proton and of the electron, and with ensuing a number of catastrophic inconsistencies when treated with quantum mechanics. Thanks to the use of hadronic mechanics, we did achieve a representation of all characteristics of the neutron in its synthesis from the hydrogen, and jointly we developed a technology capable of synthesizing negatively charged, strongly interacting particles, including negatively charged nuclei, which as such are attracted by natural positively charged nuclei by therefore in establishing the possibility of a basically new nuclear fusion without the Coulomb barrier that has prevented the achievement of nuclear fusion to date.
Beyond neutrons, Sir Professor Santilli is certain quantum mechanics is incomplete in other ways.
Another clear example of the lack of completion of quantum mechanics and therefore of quantum chemistry is the lack of a truly attractive force between valence electron pairs, evidently due to their equal charge, with consequential lack of an effective model of molecular structure and evident environmental implication in combustion. Thanks to the construction of the covering of quantum chemistry into hadronic chemistry, we have indeed achieved a truly attractive force between identical valence electrons, and which has allowed us to achieve a numerically exact representation of molecular data. Those results have then allowed us to synthesize fuels without appreciable or detectable toxic contaminant in the exhaust, and put the foundation for the achievement of a full combustion of fossil fuels.
But the question remains, what about quantum entanglement? Sir Professor Santilli has long believed there are new ways to solve the problem.
As it is well known, the Webb packet of particles fills up the entire universe. Consequently, the entanglement of particles at a distance occurs through the overlapping of their Webb packets, as a result of which particles are in continuous, instantaneous communications at a distance through their Webb packets without any need for superluminal speeds. The difficult problem that requires decades for its solution is that the interaction caused by the overlapping of Webb packet occurs in volumes rather than in isolated points, as solely possible for the representation with quantum mechanics. Consequently, the solution of the problem requires the construction of a new mathematics known as isomathematics, which is essentially based on new numbers, new functions, new differential calculus, and other new methods, all defined on volumes rather than on isolated points, with consequential advances in virtually all quantitative sciences, including the new conception of life and its representation via Vaugeauclis hyperstructures.
Engineer Simone Bartoli outlines some of the industrial applications of the EPR argument that he has personally supervised.
During our 2020 teleconference, we have reviewed studies by various authors. The recent verifications of the EPR argument by Ruggero Maria Santilli, published in the refereed mathematics journal Ratio Mathematica, and their application for the development of new technologies not describable by quantum mechanics, such as the laboratory synthesis of the neutron or of other negatively charged particles, and a basically new controlled nuclear fusion called hyperfusion without the emission of harmful radiations. The latter, in particular, is based on the synthesis of whole negatively charged light nuclei and their fusion with the corresponding natural positively charged nuclei, such as deuteron, thus eliminating the Coulomb barrier that has prevented the achievement of nuclear fusion to these days. The two nuclei are attracted with the same force that would normally repel them if they were identical, thus making nuclear fusion simply unavoidable. It is hoped that the recent verification of the EPR argument, without which the new hyperfusion will not be possible, are subjective to due scientific process by our interested colleagues for its proper development.
you.